Hello. Today, I would like to introduce the ADS9324 evaluation module and to highlight the GUI and key features you can evaluate using this module. To start, here is the box the ADS9324EVM will arrive in. The box will contain an evaluation kit user guide that explains how to download the GUI and other related software required to run the module. The box will also contain the evaluation board inside an ESD safe package. Removing the device from its package, you can see the ADC chip itself here in the middle of the board. All 16 channels are RAID on the left side. On the back side, you'll notice that there are connectors for communicating with the FPGA controller card. You will also need this controller card to communicate with the evaluation module. The FPGA controller card is the TSWDC155EVM, and it can also be found on TI.com. This controller card also has the same connectors as the ADS9324EVM. Connecting them like this allows you to evaluate both of these modules. Now, we can move to the ADS9324EVM GUI and take some measurements. Step 1 is to start the board startup stage by clicking the board startup button. Once the button is clicked, the USB is initialized, the FPGA controller, the TSWDC155EVM, is powered up, and the FPGA controller card is also programmed. You can track these changes by looking at the LED lights on the controller card. For example, the majority of the lights will turn on at the FPGA power stage, and LED D1 will light up once the FPGA programming is complete. You can also see the lights at the bottom right of the GUI begin to turn from red to green as each of these steps are completed. Once all the lights on the bottom right turn green, the next stage is to initialize the ADC itself. When this button is pressed, a series of registers are written to bring the ADC to a default state. Once the ADC is fully initialized, a new tab will appear in the top left called Device Registers. The Device Registers tab lists all the ADC registers that can be manipulated with the GUI. However, for ease of use, we have created this block diagram with some of the most used registers accessible via small pop-up windows that appear when clicking on each of these blocks. For example, clicking on the LPF block allows you to change the low-pass filter from 30 kHz to 400 kHz. Each of these settings can be changed for each individual channel. Another commonly used feature is the digital averaging filter, found within the digital and data interface block. We have a moving average filter, an FIR filter, and an oversampling OSR filter, otherwise known as block averaging. Block averaging can also be done up to 128. Next, we can move on to the data capture window, where you can take time domain and FFT plots. There are multiple settings on the data capture window. You can select what kind of capture to take. Usually, we take single capture. The sample count can also be set. A moderate number is 65,536 samples. The ADC sample rate can also be selected. For this example, we will set it to 1 MHz. The input frequency per the user's input signal can be input here, so the FFT window can calculate the SNR, the THD, and other similar values. In this example, we have applied a 2 kHz 8.9 volt peak-to-peak input signal from an audio precision instrument to all 16 channels. When we press the Capture Data button, the sine wave appears. You can click and drag to zoom into the sine wave and see the signal was accurately read and converted by the ADC. In the event that a different signal was applied to each channel, you can select the channel button at the top of the graph to select which channels are visible. At the bottom of the screen, the average, minimum, maximum, and standard deviation of ADC output codes is shown for the selected channels. We also have some windowing features on the bottom left. The data from the plot can also be exported by right-clicking the plot and clicking Export. In the FFT window on the bottom of the screen, the selected channel's FFT plots will populate the fundamental SNR and THD values. For linearity analysis, a saturated signal must be applied. Since we are in plus or minus 5 volt input range mode, we can apply a signal that is 10.5 volts peak to peak. In this case, channel 1 is selected, so the signal must be applied to channel 1. We will select 64 hits per code and click the Get INL/DNL button. This capture will take some time, as 64 hits per code are being acquired for every single point on the sinusoidal wave. If you take a larger number of hits per code, the INL will continue to average out and by extension improve. Finally, if you go to the Device Registers page, all of the registers shown in the ADS9324 datasheet are accessible. For example, you can implement daisy chain mode by going to this register block, EN_OFS_binary. Within this register block, you can enable the daisy chain mode. Once a change has been made, you need to hit the refresh button to ensure the ADC and the register map are synced. That's all for this EVM unboxing and tutorial video. Please feel free to post any questions to our experts on e2e.com. Thank you for your time.